So our essential question today is, how do you analyze a quadratic equation? Some vocab review. You guys should have this in your notes already from a couple days ago. Standard form of a quadratic equation is ax squared plus bx plus c. Factored form is when you have the binomials x minus c times x minus d. And also note, I don't think you guys had this last time, that c and d are the x-intercepts of the function. We'll go into more detail with that in about 2 weeks, I think, but for now know that c and d are the x-intercepts of the function. And also notice that they're in the asylum, so it looks like negative c, but really positive c is the x-intercept. And finally, vertex form, which we've studied. Domain is the x value, input, independent variable. A question you want to ask yourself when you're determining domain is, what values can you substitute for x? The range is the y value, output, or dependent variable. And the question you want to ask yourself when determining range is, what values do you get out of the function when you're solving for y? Looking at each of those quadratic functions, they all had an a value that was being multiplied by the x squared term. So we're also going to take a look at what that a value does to the function. If a is positive, the parabola will open up. If a is negative, it reflects across the x-axis, which means the parabola opens down. The next couple of bullet points are about how it stretches or condenses the parabola. So if a is greater than 1, it vertically stretches the parabola so it gets thinner. If a is between 0 and 1, if the absolute value of a is between 0 and 1, the parabola is vertically compressed, which means it gets wider. All right, so lots of vocab here. We're looking first at the axis of symmetry. The symmetry is an imaginary vertical line across which the parabola is reflected. The equation x equals h, where h is a constant number. If the equation is in factored form, and you have two x-intercepts, you find the midpoint, and that will be your axis of symmetry. If there's only one x-intercept, that is your axis of symmetry. Standard form of the equation, the formula to find the axis of symmetry is x equals negative b over 2a. So notice that b is the value that you're multiplying by your x, and a is the value that you're multiplying by your x squared. So that's where those values are coming from in the formula. And finally, given vertex form, x equals h. However you're shifting that graph left or right, that's where you'll find your axis of symmetry. All right, so let's take a look at a couple of examples for finding our axis of symmetry. These are both looking at x-intercepts. So our first example, we've got two x-intercepts. So the axis of symmetry will occur where the midpoint of the x-intercepts are. So we take 1 plus 7 and divide by 2. So we're averaging those x-intercepts. Again, I'm getting those values right there. So 1 plus 7 is 8. 8 divided by 2 is 4. So x equals 4 is the axis of symmetry. And that's a vertical line right through the center of the parabola. The second piece of our directions are to identify the domain and range. For all quadratic functions, you can put any value into the quadratic function, square it, multiply it, add and subtract with it. So our domain for all quadratic functions is all real numbers. The range, if you notice, the parabola either starts or stops. It has a minimum or a maximum value. So if the parabola opens up, as it does on our first value, or our first parabola, the y values, or the range, will be greater than or equal to the y coordinate of the vertex. So the vertex is right here. And in this case, because I don't have the equation for the graph, I'm going to estimate it's right around -4. It looks like it's a little bit lower than that, but I'm going to estimate our range to be greater than or equal to -4. On our second parabola, we have one x-intercept. So this is that line across which our parabola is reflected. So x equals -3 is the equation for our axis of symmetry. Again, domain for all quadratic functions is all real numbers. And our range, this time the parabola opens down, so our range is y is less than or equal to, and in this case, our vertex is at -3, 0, so the y coordinate is 0. So our range is y is less than or equal to 0. Now we're going to take a look at finding the axis of symmetry from the equations. So our first equation is in standard form. So we're using the formula x equals negative b over 2a. So we have to identify the a and the b values. The a value comes from the coefficient of your x squared term, in this case 1. And the b value comes from the coefficient of your x term, which is 7. So we substitute that into our formula. The opposite of 7 is negative 7 over 2 times our a value, which was 1. So we have an axis of symmetry at negative 7 halves. So that's the first part. The second part is domain and range. So again, domain for all quadratic functions is all real numbers. And the range will occur at the y-coordinate of the vertex. So to do that, we take the x value and substitute it back into the function for x. We take a look at our a value because a is positive. That tells us that the graph opens up. So our range will be y is greater than or equal to, and then we'll substitute this negative 7 halves into our function for x. And when we evaluate that, oops, this is negative 7 halves in our x spot. So we get 48.75. So our range is all y values greater than or equal to 48 3/4. Next, we're going to look at finding the axis of symmetry from an equation in vertex form. So this one is a nice easy one. We just pull the vertex right out of the equation. Again, the one thing you need to remember is that asylum. So when we're taking a look right here, the graph got shifted not right 3, but left 3. So our axis of symmetry is x equals negative 3. Identifying domain is easy, all real numbers. Range, we do the same thing we did on the last example. We take our negative 3, substitute it back into the equation for x. So when we do that, what happens is inside our parentheses, negative 3 plus 3 cancels to 0. 0 squared is 0, times negative 4 is 0. So we got our y value is 9. This time our a value is negative, so that means the graph opens down. So our range will be y is less than or equal to 9 because the graph is opening down. Next piece we're going to look at is the vertex, which we've already kind of found with looking at domain and range. We just haven't put it into an ordered pair. So the vertex is kind of the turning point. It's the max to the min of the parabola, and it's always on the axis of symmetry. The x-coordinate for the vertex is the equation for the axis of symmetry. These little dots here that kind of form a triangle, obviously my board is off, means therefore. So the x-coordinate is the axis. Therefore, substitute that number in to solve for y. So for this example that we have here, this is one where we know the two x-intercepts. So we average those to find the axis of symmetry. So our first x-intercept is negative 3. You can also get that from here, taking into account the asylum. Our second x-intercept is 1. Again, we're getting that from here, the opposite. The average of negative 3 plus 1 is negative 1. So the equation for our axis of symmetry, x equals negative 1. Again, to find the y-coordinate for your vertex, you substitute negative 1 into the equation. So we're looking at y equals negative 1 plus 3 times the quantity negative 1 minus 1. We end up with 2 times negative 2, or negative 4. So the ordered pair for our vertex is negative 1, negative 4. We're looking at the coordinates of the vertex in standard form. And again, we're focusing on domain and range for all of these examples. So to find the coordinate of the vertex, the first step is to find the x-axis, the x-coordinate, or the axis of symmetry. So again, we're identifying b and a from our standard form. B, remember, is that value that you're multiplying by x, the coefficient of x, and a is the value that you multiply by your x squared term. So in this case, we have an a value of 1 and a b value of -7. So substituting that into our formula, the opposite of -7 is 7, all over 2 times 1, which gives us an x-coordinate of 7 halves. So again, that's the x-coordinate for the vertex. Substituting that back into the equation to solve for y, and this one gives us a y value of -1/4. So finally, we write this as an ordered pair. Our x-coordinate is 7 halves, and our y-coordinate is -1/4. The second piece was the domain and range. It's a quadratic function, so domain is all real numbers. And we have to take a look again at the a value to determine if the graph opens up or down. Our a value in this case was +1, so our graph opens up. So y is greater than or equal to the y-coordinate of our vertex, -1/4. Looking at vertex in factored form, so we find the x-intercepts. So our first x-intercept is the opposite of what's here, so x equals -5, again remembering the asylum. Our second x-intercept is the opposite of what's in the second set of parentheses, so x equals 2. To find the axis of symmetry, we average our x-intercepts, so we have -5 plus 2 all over 2, or -3 halves, so that's the x-coordinate of the vertex. Taking that value, substituting it into the function, and evaluating for this one, we get -12.25, or -12 1/4. Talking about domain and range, it's a quadratic function, so our domain is all real numbers. Looking at the a value, there's no coefficient outside those parentheses, so our a value is +1, so it opens up. So our range is greater than or equal to the y value of our vertex, -12.25. Also, let me back up. We need to write our vertex as an ordered pair. So the x-coordinate was -3 halves, and the y-coordinate was -12 1/4. And I believe this is the last one, looking at the vertex from vertex form. So obviously, all we have to do on this one is pull the vertex out. So the transformation in this case was left 5, because we're looking at the asylum. It looks positive, so really we shifted left 5. Outside the asylum, it's normal, so we went down 6. Remember, inside the asylum is always a horizontal shift or a horizontal scale change. If you're adding or subtracting, it's a shift. If you're multiplying or dividing, it's a scale change, and that would be horizontal if it's inside the asylum. Anything outside the asylum is vertical. Again, adding or subtracting is a shift. Multiplying would be a scale change. So our axis of symmetry in this case is x equals -5. We don't have to solve for y. We're given the vertex in vertex form. So we have -5, -6 is our vertex. Sorry if you're seeing all this. I was trying to scroll down to see if I had one more page. And the next page is the assignment. So that is the lesson for today. So we will see you in class tomorrow.